Hi, this is Mrs. Doris with Lesson 2-4, Solving Equations with Variables on Both Sides. We have two objectives in this lesson. First, students will solve equations with variables on both sides. And second, students will identify equations that are identities or have no solution. An identity is an equation where any real number will work. The reason this is so important is equations are very useful in solving real-life problems. To solve an equation with variables on both sides, you can use properties of equality and inverse operations to write a series of simpler equivalent equations. Problem 1. Solving an equation with variables on both sides. What is the solution of 7k plus 2 equals 4k minus 10? When you have variables on both sides, the very first thing that you should do is to move the variable term from one side to the other. In this example, we have 7k on the left side and 4k on the right side. The only way that I can move one of these to the other side of the equal sign is by adding or subtracting. In this case, because they are both have positive coefficients, we're going to have to subtract. And I'm going to choose to subtract 4k from the left, and therefore I have to subtract 4k from the left using the subtraction property of equality. The reason I chose to subtract 4k is because I can see it cancels out on the right side, and on the left side, when I bring down what I have left, 7k minus 4k would be 3k. Bring down my plus 2. And on the right side, I have 0 minus 10, which would be negative 10. And I chose this because you can see that I have a positive coefficient. And if I can keep the coefficient of my variable positive, I prefer to do that. You're less likely to make a mistake in doing it that way. All right, so there's our first step, and now this is just like lesson 2-2. We have 2 steps left. Here's our equation. 3k plus 2 equals negative 10. The last thing that was done to the k in this case was adding 2, so we're going to subtract 2 from both sides. Plus 2 minus 2 is 0, so I'm going to bring down my 3k. And negative 10 minus 2 would be negative 12. Dividing both sides by 3 to undo the multiplication. 3 divided by 3 is 1. 1 times k is k. And on the right side, negative 12 divided by 3 is negative 4. Now, as always, you should check your answer. To check it, we're going to go back to the original equation. 7k plus 2 equals 4k minus 10, and we're going to substitute in negative 4 for our k. Now, evaluating the left-hand side, 7 times negative 4 is negative 28. On the right-hand side, 4 times negative 4 is negative 16. Bringing down the remainder of the problem. And then negative 28 plus 2 is negative 26 on the left side. On the right side, negative 16 minus 10 is negative 26 as well. So we have a correct answer. K is equal to negative 4. Problem 2. using an equation with variables on both sides. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. In how many months will the copier pay for itself? All right, well, how many months? There's our variable. So I'm going to choose M to represent the number of months. All right, so what we're going to do is write an expression for using the old copier and then write an expression for the new copier. We are assuming in this problem that the old copier was paid for and there is no more cost associated with it other than the electric bill. So each month they are paying $112 for to use the old copy machine, and we could use 112 times M to represent the amount of the electric bill. That cost needs to be equal to the $650 that they paid for a new energy-saving copier plus the $88 per month that they are spending for a new copier. So here's our equation. When these two amounts are equal, then the $88 a month for electricity will certainly be cheaper than $112. So here we have a variable on both sides. Since 88 is smaller than 112, I'm going to subtract 88M from each side. Whenever you have variables on both sides, you want to make that your first priority to get the variable on just one side of the equation. All right. On the right side, you can see that plus 88M minus 88M cancels out. On the left-hand side, 112M minus 88M would be 24M. All right, so we have 24M is equal to $650. And then our final step is to undo the multiplication. So we're going to divide by 24. And M would equal, okay, this is not going to come out evenly. So it looks like 27.083 with a 3 repeating. So we can say that this would be, M is approximately, and in this case, because it won't quite be paid for in 27 months, I would tend to round it up to 28 months, only because by 28 months, the new copy machine will be fully paid for. Problem 3, solving an equation with grouping symbols. Our first priority when we have grouping symbols is to remove those parentheses. So in this case, we're going to have to use the distributive property. 4 times 2y plus 4 times 1. On the right-hand side, we have to do the same thing. 2 times y is 2y minus 2 times 13. All right, and simplifying, 4 times 2y is 8y. 4 times 1 is 4. On the right-hand side, we have 2y minus 2 times 13 is 26. Now, my next goal is to get my y on one side of the equation. And I'm going to choose to remove the y from the right side to maintain a positive coefficient for my y over on the left side. So 2y minus 2y is 0. 0 minus 26 is negative 26. Be very careful about that. When you end up canceling something out on the right side, making that equal to 0, 0 minus 26 is going to be negative 26. So you want to make sure that you take that minus sign with the 26. On the left, 8y minus 2y is 6y, and we'll bring down the plus 4. Now, we have 2 steps left. We're going to undo the addition by subtracting 4 from each side. That leaves us with 6y equals negative 26 minus 4 is negative 30. And then divide by 6 to get y equals negative 5. And again, check your answer to make sure that it works in the original equation. All right, the second one, we're going to do the same thing. I am going to take a slight shortcut at the beginning and not show, I'm just going to show what I'm multiplying up here. 7 times 4 is 28, minus 7 times a would be a minus 7a. On the right-hand side, 3 times a is 3a, minus 3 times 4 is 12. Now, in this case, I'm going to add 7a and move it to the right-hand side. Also, when you're doing this, please show what operation you're using. Don't just write 7a, put plus 7a. Minus 7a plus 7a is 0, so 28 minus 0 is 28. On the right-hand side, 3a plus 7a is 10a minus 12. All right, now I'm going to remove my minus 12 by adding 12 to both sides. Minus 12 plus 12 is 0. Now I have on the left 28 plus 12 is 40 equals 10a. And undoing the multiplication of 10, I'm going to divide by 10 on both sides. And 40 divided by 10 is 4 is equal to my a. And once again, check your answer to be sure that it gives you a true statement when you substitute it into the original equation. Now, some equations do not have an answer. An equation has no solution if there is no value of the variable that makes the equation true. An identity is an equation that is true for every possible value of the variable. So in our next problem, we're going to work to identify identities and also equations with no solution. All right, so let's proceed. I've got to get rid of parentheses, so I'm going to distribute. 3 times 4b is 12b minus 3 times 2 is 6. On the right-hand side, I'm simply going to bring down what was written, negative 6 plus 12b. Now, the next step should be to get our variable on one side of the equation. And I can look at this already and see I'm going to have a problem, because to get rid of plus 12b on either side, I'm going to have to subtract 12b. Plus 12b minus 12b cancels out. 12b minus 12b also cancels out. And I have 0 minus 6 would be negative 6 on the left. And on the right-hand side, I have negative 6 plus 0, which is negative 6. Now, this is a true statement. So what this tells me is that this is an identity. Identity is one way that you can say that you have a correct answer. Another way of saying it is you can write b is equal to any real number. And you should know that you can write this both ways. All right? In the next problem, again, let's get rid of the parentheses on the right. So I'm going to bring down the 2x plus 7 on the left. Distributing, I have negative 1 times 3 is negative 3. And I'm going to add the opposite up here so I don't make a mistake. And I have negative 1 times negative 2x, which would be a plus 2x. All right, now in this case, again, I'm going to move my variable, attempt to move it to the other side. And you can see plus 2x minus 2x cancels out. And on the left side, 2x minus 2x cancels out. And in this case, I'm left with 0 plus 7, which is 7, on the left. And on the right-hand side, I have negative 3 plus 0, which is negative 3. This is a false statement. 7 is not equal to negative 3. So when we have a false statement, that's when we say we have no solution. All right. Another way that you can indicate there is no solution is by saying x equals, and this symbol right here is called the null set. It's a 0 with a slash vertically through it, so, or kind of semi-diagonally through it. So x equals the null set. And that means that there is no real numbers that will make that equation true. All right, let's summarize our steps then to solve an equation. Step number 1, the first thing that you want to do is to remove any parentheses or other grouping symbols. This may involve the use of the distributive property. Another something that you may need to do is to clear decimals and fractions, and you can do that by using one of your properties of equality. Step 2. Combine like terms on each side of the equation. Step 3, use properties of equality to get the variable terms on one side of the equation and the constants on the other side. Step 4, use the properties of equality to solve for the variable, working backwards. 5, check your solution in the original equation. If you do all 5 steps, then you will make sure that you have a correct solution. This concludes lesson 2-4. If you have any questions, please bring those to class. Thank you.